All right, buckle up, everybody, because we're diving deep into something pretty wild today. Quantum singularities.
Yeah, these things are sending ripples through the physics world.
We're talking about these hypothetical points of, well, infinite energy density,
Mhm.
thought to be at the heart of, like every single particle.
It's some mind-bending stuff.
It is. But stick with us, because if this whole theory actually pans out, it could completely revolutionize how we understand the universe.
Mhm.
And, that's going to have some pretty major implications for everyone. Scientists, entrepreneurs, you name it.
Absolutely. We're going to be unpacking a whole stack of research that's suggesting that quantum singularities, or QS for short,
I like that.
could actually be the true source of mass for particles, potentially replacing, like that Higgs boson in the standard model.
Whoa, 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 hold on. You're saying we might be ditching the Higgs.
Well, not ditching exactly, but think of it this way. You're probably pretty familiar with the Higgs boson.
Of course, yeah.
But this theory is saying there might be a deeper, more fundamental explanation, like a root cause for how particles actually get their mass.
Okay, so we're kind of like rewriting the rules of physics here, right?
Yeah, pretty much. It's a pretty big paradigm shift.
I'm all for it, but what's the evidence? Like, what makes scientists think this radical idea could be true?
Well, there are a few things. First off, physicists have observed some anomalies, let's say, in how the Higgs boson decays at the Large Hadron Collider. These anomalies, they don't really fit neatly within the standard model, but QS theory, that could potentially explain them.
Okay, so like the current model, it can't really explain everything we're seeing.
Exactly. For example, there are certain decay pathways that, the standard model predicts, but we haven't actually observed them. And then there are others showing up at rates that are just a little bit off.
So it's almost like the universe is dropping these little hints.
Yeah, like saying, hey, something's not quite right with your picture here.
Exactly. So these anomalies are like missing pieces of the puzzle.
Exactly, and QS theory just might be able to fit those pieces into place. Now let's take a second and, dive a little deeper into what a quantum singularity actually is in this context. Imagine like a tiny, tiny black hole inside every single particle, and it's warping space-time and defining, the particle's properties.
Wait, so instead of this Higgs field giving particles mass, it's these mini black holes that are kind of pulling everything in.
Right, exactly.
That's pretty wild.
Yeah. But here's the thing. It's a concept that could potentially unify all those seemingly separate forces of nature.
You're talking about like gravity, electromagnetism, the strong and weak forces.
The whole shebang. What if all of them, all of those forces, actually emerge from, the interactions of these quantum singularities? It'd be like a grand unified theory of everything, all coming from these tiny little points of infinite energy.
I'm starting to see how this isn't just some abstract physics problem. Like, if this is true, it could have some pretty mind-blowing implications. For everyone, not just physicists.
Absolutely.
We're talking, like, potentially unlocking these crazy new energy sources, maybe even figuring how to manipulate gravity itself.
That's right.
But let's not get too ahead of ourselves here. What other mysteries could QS help solve? I mean, besides unifying all the forces.
Okay, well, one of the biggest head-scratchers in physics has always been quantum entanglement.
Ah, yes, spooky action at a distance.
Exactly, where two particles are, like, linked, and they can influence each other instantaneously no matter how far apart they are.
And it's like, how do they do that? It's wild.
Right, but here's the thing. If these particles are, at their core, connected through their quantum singularities, maybe resonating across dimensions or something, entanglement might not seem so spooky anymore.
It's almost like these singularities are like the threads of reality, connecting everything in ways we don't even understand yet.
Yeah, that's a great way to put it.
And what about wave function collapse? I mean, that's another one that's always kind of tripped me up.
Okay, so wave function collapse, right? It's that thing in quantum mechanics where particles exist in this weird superposition of states until they're observed, and then their wave function, bam, collapses into a single state. It's like they choose a reality when we look at them.
Like they know they're being watched.
Right. It's bizarre. But what if it's our observation, maybe even our consciousness somehow, that interacts with the singularity and causes that collapse? Like we're directly affecting it just by looking.
Okay, now we're really getting into mind-blowing territory.
Yeah, it gets pretty deep.
So we've got these like anomalies popping up in experiments and these big mysteries that QS could potentially explain. But is there anything more concrete, like actual evidence for this theory?
Well, there are definitely a few key places where QS theory makes predictions that are different from what the standard model says. Like one is the Lamb shift. It's this tiny energy level shift in hydrogen atoms. Now, the standard model, it can explain most of that shift, but there's this little discrepancy that QS theory could account for by suggesting that those quantum singularities in the vacuum are actually influencing the energy levels.
So it's like they're causing a tiny ripple effect.
Exactly. And then there's the Casimir effect. You've got two uncharged metal plates in a vacuum, and they experience this attractive force. Again, the standard model predicts it, but QS theory suggests the force might actually be stronger than predicted because those singularities in the vacuum are adding to it.
Okay, so these are actual experiments that we can do here on Earth to test this.
Absolutely. And then, there's the whole world of quarks and the strong force, which, by the way, is described by quantum chromodynamics, QCD.
QCD, right, I've heard of that.
Yeah, it's a mouthful. But the thing is, quarks, those things are always bound together in groups. You never find one just floating around by itself.
Right, always in those little groups.
Exactly. And the mechanism for that confinement, how they're held together so tightly, that's still a mystery.
Yeah.
But QS theory suggests that the strong force itself could actually emerge from the energy potential, of quantum singularities within those groups of quarks or hadrons.
So it's like each hadron is a little mini universe with its own rules governed by these singularities.
That's actually a fascinating way to think about it. And there's a chance that we might actually see evidence for this in these lattice QCD simulations. There are these complex computer calculations that physicists use to study the strong force. QS theory predicts there should be some anomalies in those simulations that haven't been observed yet, but they're actively looking. Oh, and there's even some hints coming from, like, astrophysics. Observations are suggesting that the fine structure constant, that thing that governs how strong electromagnetism is.
Right.
It might actually vary a tiny bit across, like, huge, vast cosmic distances.
Wait, really?
Yeah, and that's a big deal, right? Because it's supposed to be a constant.
Yeah, that's kind of in the name.
Right. But QS theory could actually explain those variations if singularities, have these different energy states across the universe.
Okay, so now we're talking about overturning, like, some of the most fundamental constants in physics.
Yeah, it's pretty wild.
It's a lot to wrap my head around, but okay, let's just say for a minute that this whole theory turns out to be right. What are the implications? Like, what could we actually do with this knowledge?
All right, so that's where things get really exciting, but also, a bit speculative. Remember how we were talking about electromagnetism possibly being like an emergent property of these quantum singularities?
Yeah, instead of being like this fundamental force that's mediated by photons,
Yeah.
it could actually arise from the interactions between singularities and those vacuum fluctuations they're creating.
Exactly. And if that's true, it kind of opens up this crazy possibility. Like, what if we could directly manipulate those singularities using electromagnetic fields that are tuned just right?
Hold on, are you saying we could actually control these singularities?
Well, we're deep into theoretical territory here, but just think about it for a second.
I mean, what would that even look like?
If we could manipulate them, we might be able to unlock completely new ways of producing energy, ones that just dwarf what we can do now.
Yeah.
Tap into that huge amount of energy locked inside these singularities, maybe even harness the energy of the quantum vacuum itself. 0-point energy, as it's called.
Okay, wait, so no more reliance on fossil fuels or even nuclear power. We could have, like, clean, unlimited energy just drawn straight from space-time.
Potentially, yeah.
I mean, are we talking about tech that's centuries away, or?
It's hard to say for sure. I mean, the technological hurdles are going to be immense. But remember, we're still pretty early on in understanding this whole theory. It wasn't that long ago that things like lasers and transistors were just theoretical ideas, right?
Yeah.
So it's important to stay grounded, but it's also important to keep an open mind about what might be possible.
Okay, I'm trying to keep an open mind, but you're really stretching my imagination here. What about other potential applications besides, solving the world's energy crisis?
Well, there's the potential for manipulating gravity. Like, if gravity itself comes from these interactions of quantum singularities, then changing those singularities could, in theory, allow us to manipulate gravity itself.
Okay, now we're talking about like warp drives and anti-gravity devices. That's sci-fi stuff.
I know it sounds incredible, but the theoretical foundation is there. Look, I'm not saying we're going to be building warp drives next year, but if QS theory is right, it opens up these possibilities for exploration in the long run. But let's maybe step back from those, those really out there ideas for a minute and think about something a little more practical.
Okay, yeah, let's bring it back down to earth a bit. What about something with a more immediate impact?
Well, one area where QS could have a massive impact is in quantum computing. Imagine a quantum computer that's powered by, like, precisely controlling individual singularities. The computational speeds and power, it'd be unimaginable compared to what we have now.
That's something I can definitely get behind. What would that mean for fields like medicine, materials science, AI?
Oh, it would be transformative. We could design new drugs and materials with crazy precision, simulate complex systems like perfectly, and develop AI that surpasses human capabilities in a lot of areas.
So we're not just talking about like changing how we understand physics. We're talking about this whole technological revolution that could reshape, well, everything. But let's go back to those more mind-boggling implications for a second. You mentioned consciousness before. How could QS be connected to something as, complex and mysterious as the human mind?
Yeah, that's a question that's been around for a long time. Philosophers, scientists, everyone's been trying to figure that out. Some researchers think that quantum phenomena, specifically entanglement, could be playing a key role in how our brains process information and, create consciousness. Now, if these quantum singularities are like the fundamental building blocks of reality and they can do these strange non-local interactions, maybe they're somehow intertwined with like the very essence of our minds.
Wait, are you suggesting that our minds could be connected to this, like, vast network of quantum singularities, like some kind of cosmic consciousness?
It's a wild concept, I know, but it's not totally impossible. I mean, if everything is really interconnected through these singularities, like this theory says, then it raises some pretty deep questions about, who we are and our place in the universe.
Wow, this is a lot to take in. We've gone from potentially rewriting the laws of physics to redefining what consciousness even means. All right, so we've taken this deep dive into the theoretical heart of quantum singularities, explored how they can totally rewrite the rules of physics, and even, pondered their connection to consciousness.
Yeah, we've covered a lot of ground.
My brain is a little fried, honestly.
It's a lot to process. From rethinking where mass comes from and the nature of fundamental forces to imagining warp drives and a universe interwoven with quantum consciousness.
It's pretty wild. So where do we go from here? What does all this mean for everyone listening, for professionals in all these different fields, anyone trying to wrap their head around a world, on the edge of these groundbreaking discoveries?
That's the million-dollar question, right? Even though quantum singularity theory is still in those early stages, it's super important to stay informed and engaged with how it develops. I mean, these ideas have the potential to impact, well, everything. From energy and material science to computing, even philosophy.
For sure. So what should people be paying attention to? What are the key developments or breakthroughs that could signal we're really moving towards this new paradigm?
Well, definitely keep an eye on those experimental anomalies we talked about, like those deviations in how the Higgs boson decays, any unexpected fluctuations in vacuum energy, and those strange patterns in quark confinement.
Right.
Those could be, the breadcrumbs leading us to a deeper understanding of how things really work. If this QS theory is correct, we should see more and more of those anomalies as our experiments get, more precise.
So we're all kind of like detectives, looking for clues to solve the biggest mystery there is.
Exactly. And don't be afraid to think outside the box, because if this theory is right, it means we've only just scratched the surface of what's possible. The implications are huge. For technology, for how we understand the universe, for the nature of reality itself, it's pretty profound.
Absolutely. So for everyone listening out there, what's the takeaway message? How can they apply this knowledge to their own lives, their work, their understanding of the world?
I think the key thing is to embrace that spirit of scientific curiosity. Think about how this new framework, even though it's still speculative, could shake things up in your field. Could quantum singularities change how we store energy in your industry? Lead to breakthroughs in materials with properties we haven't even imagined yet? Or maybe even inspire completely new ways of thinking about information processing or AI?
It's like this theory is giving us this whole new lens to view the world through, to see connections and possibilities that we never even considered before.
Exactly. And beyond those practical applications, there's this deeper, like, philosophical question here. If everything is fundamentally interconnected through these quantum singularities, what does that tell us about our place in all of this? Does it point to, like, a deeper level of unity and interconnectedness than we ever thought possible?
It's a pretty profound thought. We're not just talking about rewriting physics textbooks here. We're talking about redefining our understanding of reality and our place in it.
And that's what's so amazing about science, isn't it? It's not just about finding answers, it's about asking the right questions, about pushing the boundaries of what we know and what we can imagine. And who knows, maybe one of our listeners will be the one to, like, finally unlock the secrets of quantum singularities and bring in this whole new era of scientific understanding.
So to all our listeners out there, we'll leave you with this. Keep questioning, keep exploring, and keep an open mind. The universe is full of incredible things, and this journey of discovery, it's just getting started.
Yeah, and remember, even if this quantum singularity theory turns out to be, a dead end, just exploring these ideas, challenging what we think we know, that has value in itself. It makes us think bigger, it deepens our understanding, and maybe even helps us see the world in a whole new light.
Well said. That's what the deep dive is all about. Thanks for joining us on this incredible journey, and until next time, keep diving deep.